In this video, we're going to go over the eye model. So as you can see off to the side, we have our terms. There are 14 terms for this model's practical. We're going to start off with the layers. The outer white layer that is covering this model, with the exception of this area that it has been cut out, is our sclera. Okay, so the whites of your eyes are your sclera. And the innermost layer, I'm going to jump a little bit, is this orangish one, which is the retina. And the retina is where all of your photoreceptors are, so the receptors that are sensitive to light. As light is coming into your eye, though, once it hits that retina, it then needs to be absorbed, which is going to be the role of the choroid here, which is this black layer on our model between the sclera and retina, and that's going to absorb that light. Right? So sclera, choroid, retina. On the anterior of the eye, so where you can see the color of a person's eye, you have a clear coating over top of that. That's called the cornea. So the cornea is kind of this protective layer, but it's also going to help diffract light as it enters the eye. For our model, the cornea is a separate piece. I'll show you how that looks in a second. Just behind it, you have the colored portion of the eye, the pigmented portion, which is called the iris. And in the iris is an opening, simply just a hole, that we refer to as the pupil. So give me just a second. I'm going to open this model up. So here is our cornea. Here is our iris, and you can see there's a pupil, so this opening here. This opening is going to be changed based on the amount of light or lack of that's incoming. So the iris is going to either dilate or constrict. So if it's dilating, we are needing more light. If it's constricting, there's a lot of light, and maybe we need to control how much is entering. And if I bring our eye back, we have this structure here just behind that iris and pupil called the lens. Right? This is what is going to focus our vision. So just like the lens of a camera is going to focus an image, the lens of our eye is going to focus the image. The area or space that is in front of the lens, so cornea, iris, pupil, that's going to make up our anterior cavity. So everything in front of the lens. This kind of section is filled with what's called aqueous humor, so like a watery substance. And we'll talk about why we distinguish with that in just a second. So then our lens, if it is focusing, it may need to focus depending on, how far or close something is. And in order to focus that, we have our ciliary muscles that are going to pull on what we call our suspensory ligaments. Our model does not have suspensory ligaments, but you are able to see the ciliary muscles, and that's going to be this brown region here. These muscles are going to pull on the ligaments to help focus the lens. From there, behind the lens, we have this second cavity called our posterior cavity. So that is represented by this clear sphere here. This is filled with vitreous humor, and it's kind of like a gel-like substance. It's kind of jelly, and that's going to have to do with the pressure of your eye and maintaining structure. Okay. So everything that goes behind where that lens would be makes up our posterior cavity. Okay? From there, this might be a little tough for us to see. I'm going to try and hold them against one another. We have two areas where the lens is going to focus your, what we call acute vision. The dotted circle is the macula lutea. So that's the area where your vision is focused. And then the dots that are in the center, that area of very concentrated dots, is your fovea centralis. Your fovea centralis is going to be a high concentration of cones. That means this area is going to be responsible for your color vision. Everything outside of this area is going to be our peripheral. And lastly, on our model, where our retina and our photoreceptors send the axons to kind of converge towards the back, they are going to meet together to form what is yellow on our model, this yellow structure, which is our optic nerve. Okay? So our optic nerve is then going to take this information back to our occipital lobe to interpret our vision. What's interesting though is because there are no photoreceptors where all of these are joining, there's a little depression here that we refer to as our optic disc. And our optic disc, where this little depression is actually a blind spot, and our eye cannot pick up information that's being projected on this region. So instead, what happens is your brain is going to take the surrounding information and try and fill in what it suspects is in that region. And there's ways to test to find where your blind spot is. Okay? So be sure that you practice taking apart the model. The iris and lens kind of fit into the same little gap, and then the cornea has its own little layer here, or little groove to fit in, and the model just closes on top.